Hey guys, welcome back. This is Tristan. Welcome to the AP Computer Science Crash Course. This is episode 1, where we'll talk about the basics of programming in Java. If you haven't installed Eclipse yet, I have another episode for that. Go back half an episode, follow the instructions there, and you should end up on this window. Now, what you have to do is, what I'm going to do first, this is personal preference, is I'm going to go to Window, Preferences, General Appearance. So I kind of like a dark theme because it's easier on the eyes. So if you want to go here and then hit dark, just hit apply and then OK afterwards, and you should be getting this appearance. It's nicer, personal preference, whatever. So right now you see the Project Explorer, the outline task list. You can ignore basically all of this on the right first. So what you do is you go to the Project Explorer, you right click, and then you hit New, and then you make a new project. So you make a new Java project, and then it should follow with all the presets. For the project name, I'm going to be calling it APCS Episode 1. You can name it whatever you want. Everything else should be defaulted. You don't have to change anything else. So once you have that, you can just click through this. This is fine. Okay, and you should get this. Right now you have the source package, and you don't really have to worry about what that is right now. So what you do is you right click, you hit new, and then you make a new class. We're going to be calling this episode 1 for now. Make sure you check this box right here, public static void, and then it should construct basically what's called like the method header, the main method. We'll get into like what exactly a method is in a later episode, but for now you just need to know that you need these lines already pre-made, and it's done that when it's automatically made. Once you're at this point, let's talk about what Java is as a programming languages and what programming languages are essentially supposed to do in the first place. Programming languages are a way for people to express their ideas and code a computer to do whatever they want, basically. It's a set of instructions you're giving to a computer to follow and execute. There's two different main kinds, functional and object-oriented. Functional programming is pretty interesting on its own, but it's way outside of this curriculum. So if you want to learn more about that, this is not the video for you. Object-oriented programming, which is what Java is based off the premise of creating objects and modifying them to address problems. We'll get into that in later episodes. It's a very broad concept, but right now we have to learn what it is to actually write Java. Now, the Java code you see here is basically built up into 3 different building blocks, as I like to call them. What you see here, denoted by the curly brackets or braces, are blocks. Blocks are like basically the top of the building blocks. So let's go top down. Inside of these blocks are something like a statement, int x equals 6. Anything contained within a set of like space and then ended with a semicolon, which is basically the period. If we were writing in like common languages, it's a period denoting the end of this statement. Inside of this statement are expressions. So an expression would basically be, since this is a very simple statement, the whole thing is an expression. It's making a variable called x and is assigning a value of 6 to it. Those are like separate ideas, and those are the expressions found within statements. Now, one of the most common statements you're going to be seeing in this course is something called the print statement, and you type it out like this, exactly like this, by the way. Java is case sensitive, so capitalization matters. So you do system.out.println, and the good thing about Eclipse is that it autofills you by putting a bunch of this here. Whatever you want the program to say, you put in quotes in between the open parentheses at the end. So let's do hello world, because it's the most common statement printed out usually for programming languages. And we hit the green play button on the top left, run, whatever you call the class, really. and it'll ask you to save it. Click OK, and then it shows a console on the bottom here. This is the most important part of the course right now because it basically is the whole output of the program. So it'll be how you make sure that the program actually runs correctly, and if it runs at all, because it'll also put out errors here. So I'm going to click and drag it to the top right here, and since it's the only thing you're really going to be using, I'm going to drag this out and make this a little more even. This box is most of what you're going to be seeing for the rest of the series, because that's all we really need. So earlier I was talking about how Java was about modifying data, so let's talk about what exactly data is in this case. Now I'm going to be assigning 8 different kinds of data types in this window here. I'm going to be assigning them to variables, which you should know in math as a letter or symbol that is assigned a different value than what it can actually mean. The first type of data we see here is the Boolean. I'm going to call it A, and it can be either true or false, basically a 0 or 1. It's mostly used as a condition in programs to check if something is correct or even or odd, basically. The next type is called the character. It's shortened to char to make it easier to type. I'm going to call this B, and it basically is how the computer can tell like characters apart using numbers. 32 being a certain letter on the Unicode table, which I will link in the description of the video below. You don't have to use numbers though. You can use single apostrophes as kind of quotation marks. So if you want to do like L, S, and this is all case sensitive, by the way, so it basically, there's an individual number assigned to each character, being A to Z, uppercase A to uppercase Z, 1 through 0, and most of the symbols you can see on your keyboard right now. The next type is called the byte. I'll call that C. A byte can hold one of 256 different integers from -128 to 127, and it doesn't go up to positive 128 because 0 counts as a positive quote-unquote integer in this case. So most programs start counting from 0 and they go up. The next type is called the short. I'm going to call it D. And the max value it can hold is 32,767. The integer is basically the data type that can hold 2,147,483,647. A long can hold an extraordinarily large amount of integers, more than you would reasonably work with. Now, for an integer, if you try to increase it by 1, you see that you get an error, the red underline. But for a long, if you do increase the number and then add an L to it, you can go up really high. So let's replace this with a 9. You can also go negative. Basically, it has a really absurdly high maximum value that don't really even have to know. A float is a value that can hold a decimal value, because if you try to put a decimal value in any of these, you get an error. So if you want to use decimals, you use either the float, you have to add an F to the end of it, and the last bit of data we're going to be using is the double. And that can hold a large amount. It's kind of like the difference between short and int. The float is the short, and the double can hold a large amount of decimals. But you don't have to append an F to it. Now, for most of the curriculum, you're only going to be using about 3 or 4 of these types. So I'm going to remove the ones that we're not going to be using. We're not going to be using the float, the long, the short, and the byte. Character is very rarely used, but for now, the main numbered ones we're going to be using is integer and double. Boolean we use for obvious reasons, and character is for certain problems on the AP you can see. Now, you might be wondering why we even have integers if doubles can hold a good amount of numbers and also hold decimals. I'm going to show that by showing a simple print statement. Now, print statements can do more than just print like sets of characters in quotation marks. They can also print out expressions. So like 1 plus 1, that'll give us the integer 2 if we run it in the console. And look at it right there. So if we do something like 2.0, I do the decimal so that I get a decimal answer out of it. We'll talk about more later. So I get a decimal answer out of it. And if we run this program, we get a repeating decimal. But if you notice, it's truncated near the end of it, so it only holds a certain amount of decimal spaces. Now, to store all the decimal places, because it is a repeating decimal, you would need infinite storage, and that's just not realistic. So the computer or the system cuts it off at a certain point, and that is imperfect in terms of calculations. This slight deviation where it's like 0.666 and then zeros after it, that imperfection can add up and cause a good amount of errors in programs. So that's why we like to use integer, because it's more precise even though it can't hold decimal places. Okay, back to variables. You saw earlier in this list I made, I declared a bunch of variables and assigned them a ton of values. So let's go over that again. So you put the type of variable you want and you give it a name. I call it number of eggs, and we assign it a certain value. I have 7 eggs right now. You can't assign data that is invalid for the certain type that you've called. So if I try to make it a decimal, it will register as an error. The program won't run unless I either change the number or change it to double. So 7 eggs. And for naming convention, there's no real restrictions as long as the name of the variable is all one word. So you can't have separated spaces. You can use underscores though, but you don't really see that often. And by convention, programmers use camel case, where the first letter of the variable name is lowercase and every next word is capitalized. And for variable names, because you're going to be typing in a lot, if you're using the variables in a lot of calculations, it's better to keep it short but descriptive. Now, when you name a variable, you can't use reserved words, and basically everything here that's highlighted in sort of magenta color is a reserved word. So if I try to make an int and call it double, I can't, because the program is trying to interpret it as I'm making a double, but I'm also making an int, so it gets confused. I can name it capital D though. Since it's case sensitive, it knows that this isn't a reserved word. So it's good practice to avoid using reserved words to avoid errors in your programs. So let's talk about actually manipulating variables and changing up data. So right now, let's make an integer x and set it equal to 6. And we'll have a system print line for variable x. And since we found out earlier that the print line statement can accept all kinds of data, this is fine. It'll print out 6 if we run the command. So you can use any kind of basic arithmetic to change up a variable. So if I wanted to add 2 to my x variable to make it 8, I would do x plus 2, but this is just an expression. If I try to do the semicolon and end it as a statement, it won't know what I'm talking about. Like, what do you want? You just want x plus 2. You can't do that. You have to reassign the variable. And to do that, you would do x is equal to whatever x used to be plus 2. And that's a valid statement. No errors here. So if I copy and paste this line to the end, it'll print out 6 and then 8. Because you're going to be typing this out a lot, the developers of the Java language actually made shorthand for this. So every time you want to do like multiplication or basic arithmetic, you can do the variable name, whatever operation you want to do to it, and then equal sign right adjacent to each other. So no space, just connected. And then do whatever you want the operation to be with, so times 8. And make sure to add the semicolon. And so what it'll do now is it will take 6 and multiply it by 8 and set it equal to the result. So I should get 6 and 48. There you go. Now, you can do basic arithmetic with almost all types of primitive data. Obviously can't do with Boolean because there's only two. Character you can because they're represented by numbers, but you have to keep in mind the limitations of each type of data. So if we were to try and divide our 6 by 2.5, for instance, you would get, instead of 2.4, you would get 2 because it truncates it. Now, it might seem like it's rounding down, but if you try to divide like a smaller number with it, like 2.1, it would be definitely closer to 3, but since it truncates it, it doesn't round up at all. It just erases whatever was after the decimal point and sets it equal to x. This is where a double would come into place, and the double will show you the actual decimals afterwards without rounding, but it will truncate after a certain amount of decimals because it can't store all of them. So for the purpose of arithmetic, you need to know that the program follows order of operations, which means that if you set x equal to, say, x plus 2 times 3, it will do whatever's in the parentheses first, and then multiplication, and then addition, what have you. So prints out what you expect. Let's work with two different kinds of data now. We have an integer x and a double y. So let's say you want to make another integer and call it z. And another thing you can do is you can have certain variables equal to other variables, like z equals x. So now z will be equal to 6. And you can even do z is equal to x plus 2. And that will give you 8, but x will remain at 6. But for now, let's do something like x plus y. If you try to do that, you'll get an error, and that's because you're trying to add a integer to a double. What you have to do in this case is you either have to make the integer into a double or the double into an integer. Since z is already an integer, we have to do what's called casting. So casting is when you want to make one type and convert it into another. You do that by doing parentheses attached to the thing you want to convert, and whatever's in the parentheses is what it will convert into. So the way the math works out here is z will now be equal to 6 plus whatever y is with the decimals truncated, so 4. Now remember that it truncates, so even if I do 4.79, it won't round up, it won't do z is equal to 11, it will still do z is equal to 10, and to show that we can do a system. We can print it out and then show that it will be 10. Now that we're done with most of the things related to data manipulation and variables, let's introduce a new block into the mix, and that is called the if conditional. So the if is basically if you want to take a data set and compare it with another piece of information and have the program do something based on the output of the comparison. So the way to form a block is you do the if, and then the parentheses, and then you do a brace, and then another brace, which is autofilled if you have Eclipse and you just press enter. So whatever is in the parentheses is whatever you're checking is either true or false, and whatever's inside the brace is whatever the program does as a result of the condition being true. So let's say if 1 is equal to 1, and you notice that I put in 2 equals. That's because the equal is already used for when you make a variable, and since the program needs to be able to differentiate between whether you're talking about setting a variable or checking if two variables are equal, the double equals is used for that. So if 1 equals 1, we can do a system output saying yes. Since we know that 1 will always be equal to 1, the condition will always print out yes. But if I were to set it to 2, the condition is now false, so this system.out print line will never run. And to prove that the program is actually running, let's say no. So now it says no, but if we said 1 is equal to 1 again, it will say yes and then no, because whatever's in the if is executed first, and then it goes down from there. Let's set up 3 different variables here, and since we're all going to make them integers, I'm going to show you a cool little trick where you can do int a is equal to 6, and then you can separate a comma to continue the statement. Let's do b is equal to 10 and c is equal to 3. Now that's like a neat little trick you can do with assigning multiple variables of the same type. So since it's all integers, we can do that. If we try to do like a double, it wouldn't work because the comma is not used for that way. A lot of ways to compare it is what you would expect. You have equals, greater than or equal to, less than or equal to, or just greater than or less than. And to negate something, so if you want to check if something is not true, like I want to check if A is less than C, right? You know that's not true because 6 is not less than 3. But if I wanted to check a certain condition, I can put parentheses around them and then put an exclamation mark, where if there's a case that A is less than C will result in something wrong, it will output true and then the program will run. You can also connect multiple comparison statements together using the AND or the OR. The AND operator checks if both expressions on either side of it are true, not if they're both the same, because if we tried to do something like A is equal to B and A is equal to C, those are both false. So it would be like they would both be the same, but since they're not both true, it won't print it out. So if I try to print it out, you can see here it will just print out no. They both have to be valid statements. They both have to be true in order to actually execute whatever is inside of the block. So A is less than B, A is greater than C, we know that's true, so it'll print out yes, no. The OR statement is basically only one of these comparisons have to be true. So if I were to say A is less than B or A is also equal to C, we know that the second statement is wrong, the first one is right. Since only one of them has to be right, it will print out yes. An important thing to mention here is that as soon as the first comparison is valid in terms of OR, it doesn't have to check the other one. So the program, for efficiency's sake, completely skips over this. So we can do A is equal to 8 divided by 0. You know that in mathematics you cannot divide by 0. The program will always give an error. But since we already have this being true, there's no error here because it knows this is true. It doesn't have to check the other one because it's either or. If this one's true and the other one's true, then that's fine because it only checked the first one. But if we were to do an AND statement, it has to check both unless the opposite is true. So if the first one is wrong for an AND statement, it skips the whole thing completely. If the first one is right for an OR statement, it skips the whole thing completely. So that's why here, if we try to run it, it will get an arithmetical error because you can't divide by 0. But with the OR, it will skip through and will never divide by 0 and will just print out yes. For operators like these, they also fall in the order of operations. The order it takes for when it's doing comparisons is it will do the not, which is exclamation mark signifying that it's checking for the opposite case. Then it will do greater than and less than, and then the greater than equal to, and then the less than equal to. And then it will do the equals or not equals, and then it will do the AND operator, and then it will do the OR operator. So you make sure to know the list. You saw that in the conditional statement, you can check more than 2 things basically, where A is less than B and B is less than C, or C is equal to A. You know that it will check whatever, it will check left to right unless, you know, unless the AND operator is first, it will check that first. Oh, and for another thing, in case you wanted to make it so that it would only print out either yes or no and not both or just no, there's another kind of supplementary block you can add to the if block, and that's called the else block. So basically, whatever you want to do instead of the if statement will be in there if it fails. So here, what will happen is if the condition in the parentheses is true, it will print out yes. Otherwise, or elsewise, it will print out no. And another thing you can do is check for a secondary statement if the first one wasn't enough. So you can do another else if. So if the first statement is false, check this next if, and it's going to be a different set of statements and conditions to check before it tries to do whatever is in the else if. And you can keep going with this forever and keep checking more and more conditionals until you have a final else, or you can just cut it off and then whatever happens in the loop is skipped over or done, and then it moves on to the next line. Another thing you can do is you can nest blocks together. So if you want to check this statement, what you can also do is if this conditional is true, you can type in another if and check another conditional expression. So you want to check A is less than B or something like that, and then only if these two are true will it print out whatever is in here, or it will do whatever is in this part of it. So do like yes, it will only do that if both of these are true at the same time. So it's basically the same thing as using an and, except if the first one was true and the second one wasn't true, you can have like kind of an overlap here where it will either do both or just one. It all depends on what kind of program you're trying to write and what you're trying to accomplish. And that's the if and the else block. Alright, now that we got most of the basics down, let's rewind all the way to the beginning of the episode back to our first print statement. As you can see here, we have the hello world, and remember how before we were typing things in like numbers and stuff and we didn't need to use the quotes. Well, that's because the quotes are a special signifier about this kind of data, and it's not primitive data, it's a new kind of data. It's called the string. So if you remember before, we have a character and then we can do like the single quotes, right? The string is very similar where you go like string and then let's call it word and let's call it hello. It's instantiated in the same exact way as a regular variable is, but if you notice, the highlight for the actual type of data it is not like magenta-ish. That's because it's not a primitive data type. It's what is called in Java an object. Now an object is something that can hold data and do things with that data by itself. Now since hello is a series of characters essentially, it's holding each one of them in like, for presence of the most appropriate term, a string. To put it literally, this kind of data is literally a string of individual numbers that represent certain characters and its position in the string. So this hello world is a whole string, and because the print line can accept anything, it can accept this. Anything inside the quotes is fair game, and it prints it out. Now, because string is obviously not a primitive data type, you can't really do arithmetic with it. You can't like subtract or multiply it, because how do you do that with words? What you can do though is you can add strings together. This is called concatenation. This is like a special case in Java where you can use the plus sign to add certain words together, like hello world, nice to meet you, and all characters are taken into consideration. So that's why I have a little gap here, because otherwise it would be the exclamation mark and it would be printed right next to the N and there wouldn't be a space. So we can do so we can run the program and then it will show hello world, nice to meet you. In a similar way that you can put in variables to be printed out in a print line statement, you can do variables for string objects as well. So I can put in word here and it will do hello word This is another thing to point out. Java does things top down, so the reason why this isn't working is because the string word doesn't exist yet. It has no idea what it should be putting there. So what I'm going to do is copy it and paste it above it. So now word is a real piece of data. It's a real string that exists. So now I'll say hello world and then hello without a space. There you go. So what if you want to put something like a quotation mark in the actual quote to be printed? To do that, you're going to have to do something called an escape sequence, where you have to put in a backslash followed by whatever special character you want. So I can do a backslash quotation mark, so it will do hello quote world. This can get a little confusing if you're using a lot of quotes, but it gets easier with time and practice. You can recognize things better. Now, there are tons of other escape sequences that you can see in the AP Computer Science A curriculum, like N, which is a new line, and then the T, which is to tab it a couple spaces forward. And then you have the quote that I showed earlier, and also a backslash. Backslash is an escape sequence for itself because you use it to signify an escape sequence. So if you just type it twice, it will show the one backslash in case you ever need to type with it. So what it should write with this is hello, and then make a new line and put world, and then it will show a tab and then a quotation mark and then a backslash. There you go. Now, the interesting thing about strings is that since they're not primitive data types, you can't use traditional operators with them, like equal, equals, or greater than or less than. But a thing with Eclipse is that it kind of simplifies the process, so to say. This is a very weird exception. You should never be able to use an expression like this and expect it to work, because it's not checking to see if these two strings are equal as if they have the same letters in them, same string of letters. It is actually checking to see if they are exact same string. This is like a really rare exception. Normally things like this would never work because most operators don't work with strings. Since they're not primitive data, you can't usually subtract them or multiply them or use comparisons like greater than or equal to. But for some reason, the IDE makes it so that it does work. But normally the way you're supposed to do it is use something called a method. We'll get into methods later. You take the string and then you add a period to it, and then you use the equals comparator. The equals method basically lets you check to see whatever is inside of the string word. It will check to see if it is equal to whatever is inside the string phrase. So it will check each character and see if they match in, capitalization and if the letters are in the right order. Because this is wrong, it will print out. It won't print out true. It will just print out false, because I've changed the letters so that one says hello and one says helo. So it will only print out false. But if I were to make it hello and hello, it would print out true and then false because of how it works. Okay, that's it for strings. You just have to know that you can't treat them exactly like you would with primitive data. And that should be the end of the episode for basics. Sorry that this was a long one. The next ones, because we've covered all the basics, will be a lot more short and more instructional than it is demonstrational. So yeah, thank you for watching. Continue on to episode 2, or take a break if you want, and I'll see you there.